Welcome everybody. We are GreenLink, a smart greenhouses system, and our team is composed of Matteo Bogoni, Matteo Impieri, Valentina Zamora, and Alejandro Ayala.
We offer to our users services of installation, control, and monitoring of IoT devices inside their greenhouses. Our architecture includes different components, starting from the web page, which communicates with the greenhouse catalog in order to manage users' information, and with TickSpeak to track their data. Following with the Weather, Environment, and Irrigation Manager, responsible for the control of the IoT devices by the use of strategies, and finally the device connector that works as a gateway between the entities and the devices. When a user is interested in our product, we make a subscription contract in which we offer the installation outside of the devices, and we assign a unique user and greenhouse's ID. Due to lack of physical devices, we also develop a device simulator connected to the device connector. As it is shown in the script, we simulate the different actuators and different sensors as different objects that interact in the same ecosystem. We emulate the environment in which the devices are placed with the respective measurements such as temperature and humidity. Using linear functions, we define the rate in which the values of the measurements change and we update them. On the other hand, the device connector is connected to the devices. In this case, we import the devices simulated, and once the measurement from the sensor is performed, it is collected and sent via MQTT to the ThinkSpeak adapter and the environment manager. When the message is from any of the manager, the device connector switch on or off the value of the actuators in order to reach the adequate measurements proposed in the strategies.
This is how you will see the interface as a user in the website. The first page, the home, allows you to visualize the current state of a specific user and greenhouse. By going on the left menu, a user can move through the web page to create a new user profile or manage an already existing one. There is this User Management tab. We'll be covered it later on this part of the process. Same thing for a greenhouse. You can go to this section and create it, update it, or delete it. Let's start to understand the irrigation management. Here we are saying that at 7 a.m. there is an existing strategy, but actually is deactivated. And here at 2 p.m. we have a 2 liters water quantity and is activated. Let's talk about the environment strategy that indicates the ground temperature and humidity that you would like to keep all time for the greenhouse. In this case, we are showing 25 degrees with 30% of humidity. Finally, the weather strategies allows to keep the same temperature and humidity for the air in the greenhouse. Also, this allows to open the window and deactivate any fan and humidifier if and only if the external weather conditions meet the temperature and humidity values indicated.
Using the User Management tab, as mentioned before, it is possible to create, update, and delete a user by communicating with the Greenhouse Catalog, our resource catalog. Are the Node-RED nodes that manage the User Management page along with its forms and the HTTP communications. Similarly to the other pages, in particular the Greenhouse one, we have 3 different branches. The first one to create, the second one to update, and the last one to delete user accounts. They all start with a form, like this one, which collects data that are then used to make an HTTP request by using the HTTP node to the catalog. After the HTTP request, the nodes are used to visualize the result of the operation in the first and in the last branch, while in the central one, the update, it is used before another form to collect the updated data. Generally speaking, the Python nodes are used to correct the formats of the data before and after being received by the catalog. For example, this one is used to correctly populate the second form of the update part with the old data. Now, using this data, I create a new user from the web page. And as can be seen here, the operation was performed correctly. It is also confirmed in the resource catalog logs. In fact, the operation got a positive result at 200 code. The Greenhouse catalog, by making use of the CherryPy library, offers REST interfaces to, looking to the user class for example, retrieve, add, update, or delete data about the users, the greenhouses, or the strategies. As can be seen right there, we have classes for user, greenhouses, and strategies. There are also similar functions to manage other system components information, which comprise the endpoints along with their function. An example could be the device connector class, which exposes a get function to retrieve information about the different device connectors, and a post function, which instead is used by each device connector to auto-register itself to the resource catalog. In fact, each component of the system, excluding the broker, TeamSpeak, and the web page, should register itself continuously to the catalog in order to maintain only up-to-date information and ensure their functioning. The Greenhouse catalog is able to automatically delete old data, allowing administrators to be aware of failed components. And this operation is performed in the lines that are shown right now, which are part of the main function of the Greenhouse catalog.
To demonstrate how the strategies work in the debug, we are going to start from the main block of the Environment Manager. It's the simplest one of the three to understand some key steps. First, we have the setup of Cherry Pie configuration and initialization of the MQTT handler with broker information, enabling both types of communication, REST and MQTT. Specifically, the Environment Manager is subscribed to an MQTT topic for sensor measurements. It periodically checks for new sensor measurements and, if it has a label, compares them to define strategies and publish the control commands based on the desired conditions. This is the while true that allows these operations, including the strategies, if activate or deactivate the window, immediately configuration. Now, if we move to the Weather Manager, it works as the previously one, but it also has to interact with the Accurate Weather API. We can see the proper coding part, the API key, which is about, but here we have the get localization that takes the name of a place and extract the code key of that place. And then we have the get weather that adds to the API weather the weather conditions using the key code of the place and get a JSON of all the measurements. Once we have this, we have the measurements, considering again a specific city. In the main, this is handled with a flag inside the while. Finally, we have the Irrigation Manager, which works as the previously ones, but it has the possibility to register more than one strategy. So in this case, the cycle or the while in general works a little different from the rest ones. Because if a new strategy, it just open the file, read everything, define if this is true or false, and include this strategy in the list.
This is the page dedicated to statistics. In this form, it's possible to insert a user ID and greenhouse ID in order to visualize real-time data and graphs about the historical data. This is the node that allows the MQTT connection, while with this Python 3 node, it's possible to set the MQTT action and build the topic in a dynamic way, according to the value passed by the form, and then use it for the subscription. Instead, the plots are obtained through REST request to TeamSpeak. In order to store data on TeamSpeak, it's necessary the TeamSpeak adapter, since it cannot work properly with MQTT messages, and it requires HTTP connection. Here, there is the MQTT subscriber class, which gets the topic and subscribe to it, in order to receive data published by the device connector. Then, these data are sent through REST communication to their respective TeamSpeak channel, according to the greenhouse ID and user ID, present in the topic. This is the TeamSpeak interface, where there are all the private information about the channel, and where it's possible to create and manage the graphs. Here, for example, it's possible to clear all the data or delete the channel. We make use of Docker with Docker Compose. That is a tool that allows us to easily manage Docker containers, simplifying the interaction between them. This is the entire project that is composed by containers, and each represents a specific microservice.